It is one of the oddest paradoxes of our time. Humanity has learned to listen to the birth cries of the universe itself, yet we struggle to listen to each other across a dinner table. With instruments more sensitive than the human eye could ever dream of being, we detect photons that have been traveling for nearly 14 billion years, carrying with them the faint echo of the cosmos as it once was. And yet, with all this power, with all this reach, we often find ourselves distracted, impatient, endlessly scrolling past the signals of our own age, unable to pause long enough to ask what they mean. Here lies the contradiction. We have tuned our antennas to the sky to catch the oldest light in existence, but our minds are often tuned only to the noise of the moment. But let us step back. What is this mysterious radiation? Why do cosmologists, astrophysicists, and philosophers alike treat it with such reverence? Why does the cosmic microwave background, a faint hiss of energy stretched thin across the heavens, matter more than any monument we have ever built, any book we have ever written, any empire we have ever raised? Because it is the oldest story we know. Imagine the universe as a vast stage. The Big Bang was the opening act, the raising of the curtain. For the first fraction of a second, everything we now see, galaxies, stars, atoms, even the space between them, was compressed into a single, hot, dense point. It was not an explosion in space. It was the expansion of space itself. Time, energy, and matter all surged outward in a great unfolding. But in those first moments, the universe was blinding. Light could not travel freely. Trapped in a dense fog of particles colliding, scattering, recombining, the cosmos was like a crowded room so packed with people you couldn't move without bumping into someone. Photons, the messengers of light, were constantly jostled. The universe was opaque. Then, after about 380,000 years, the density dropped. Atoms formed. The fog lifted. And in that instant, the photons were released free to travel. They have been traveling ever since, stretching with the expansion of space, cooling into the faint microwave glow we detect today. That glow is the cosmic microwave background, or CMB. It is not just light, it is a photograph of the infant universe, a baby picture 13.8 billion years old. Think about that for a moment. Long before Earth existed, before the sun ignited, before our galaxy had even fully assembled, these photons were already on their journey. And some of them have now landed, after billions of years, in our telescopes, our detectors, our instruments. They carry with them information about density, temperature, and structure at the dawn of time. They are signals from the cradle of creation. And here is where the metaphor deepens. The CMB is not smooth. It has tiny ripples, minute fluctuations in temperature, 1 part in 100,000. To the casual eye, these are imperfections, but those imperfections are everything. Because from them grew the structure of the universe galaxies, stars, planets, life. Without those ripples, the universe would be uniform, and uniformity breeds nothing. It is in the unevenness that meaning arises. Doesn't that sound familiar? Our own lives, too, are shaped not by perfection, but by variation. It is not in the smooth stretches of time that civilizations are built, but in the turbulence, the imbalance, the friction. The very same principle that turned ripples in the infant universe into galaxies turns struggles in human history into progress. The cosmic microwave background whispers a cosmic truth. Imperfection is the engine of creation. But here's the challenge. The CMB is faint. It is buried in noise. To detect it, scientists in the 20th century had to build instruments of extraordinary sensitivity. The story is now legend. In 1965, Arno Penzias and Robert Wilson, working at Bell Labs, pointed their radio antenna skyward and found an annoying hiss. At first, they thought it was interference, maybe pigeon droppings in the antenna, maybe background noise from their equipment. They tried everything to remove it, but the hiss remained. What they had stumbled upon without fully realizing it was the afterglow of the Big Bang. That faint hiss was the oldest light in the universe, filling all of space, whispering the memory of the cosmos itself. Here is the irony. The universe had been broadcasting this signal for nearly 14 billion years. It was everywhere, surrounding us always. But only when we tuned ourselves with precision, patience, and humility could we finally hear it. And that raises the deeper question: what other signals surround us waiting for attention? What truths lie hidden, not because they are absent, but because we are too distracted, too impatient, too entangled in noise to notice? The CMB is a cosmic metaphor for human awareness. The signals are there, faint but real. The challenge is whether we will listen. The hiss that Penzias and Wilson stumbled upon in 1965 was only the beginning. Finding the signal was one thing, interpreting it was another. To the untrained ear, it was noise. To a prepared mind, it was the oldest story ever told. Scientists quickly realized, if this glow truly was the afterglow of the Big Bang, it should be almost perfectly uniform, the same in every direction. And indeed, it was. But if it were perfectly uniform, there would be a problem. No galaxies, no stars, no us. For structure requires imbalance, seeds from which gravity can sculpt. And so the quest began. To find the tiny fluctuations, the faint fingerprints in the CMB that would reveal the seeds of everything. The first great leap came in the 1,990 seconds when NASA launched the Cosmic Background Explorer, COBE, satellite. COBE was designed to measure the faint microwave glow with unprecedented precision. What it found was nothing less than revolutionary. Tiny variations in temperature, 1 part in 100,000, etched into the fabric of the sky. Stephen Hawking would later call COBE's discovery the discovery of the century, if not of all time. Why? Because those fluctuations were the blueprint of the cosmos. They were the original ripples stretched across the sky, from which every galaxy, every star, every planet, and every human being ultimately formed. Think of it. The Milky Way itself, our home galaxy, is the grown-up version of one of those ripples. The sun, around which Earth orbits, is a direct descendant of that unevenness. Your body, made of atoms forged in stars, owes its existence to the fact that 13.8 billion years ago, the universe was not perfectly smooth. COBE's map of the CMB looked like static at first, blotches of red and blue showing slightly hotter and colder regions. But within those blotches lay the entire future of cosmic structure. From randomness came order. From imbalance came beauty. From noise came meaning. And once again, the metaphor extends to us. Civilizations too emerge not from uniformity, but from diversity. Cultures thrive not in sameness, but in variation. Democracies grow not when all voices sound the same, but when they differ and balance each other. The CMB teaches us a cosmic truth. It is the differences, the tiny fluctuations, that make the universe interesting and habitable. But COBE was only the beginning. A decade later came WMAP, the Wilkinson Microwave Anisotropy Probe. Launched in 2001, WMAP refined the map of the CMB with extraordinary precision. It gave us not only a picture of the infant universe, but also the most accurate measurements yet of its age, composition, and fate. From WMAP, we learned that the universe is 8 billion years old, that only about 5% of it is made of ordinary matter, the atoms that make stars, planets, and people. About 27% is dark matter, invisible yet gravitationally essential. And about 68% is dark energy, a mysterious force driving the acceleration of cosmic expansion. Pause on that. The CMB revealed not only the seeds of galaxies, but the profound truth that most of the universe is unknown to us. Ordinary matter, everything we see, touch, taste, and measure is but a sliver of reality. The rest is hidden, dark, elusive. The signals are there, but faint. And this is where the CMB is both science and philosophy. It whispers that the visible is not the whole story, that reality is more than appearance, that mystery is not a bug in the system, but a feature of existence. WMAP gave way in 2009 to the most detailed map yet, the Planck satellite. Planck charted the CMB with stunning resolution, refining the cosmic blueprint down to fine detail. Its map looked like a tapestry of hot and cold spots, subtle, intricate, exquisite. From it, scientists could trace the universe's structure, predict the distribution of galaxies, even test theories of inflation, the idea that in its earliest instant, the universe expanded faster than light. Planck confirmed what inflation predicted, that the universe is astonishingly flat. Not flat like a table, but flat in geometry. Parallel lines never meet. Space does not curve back on itself. And a flat universe suggests something staggering. It may be infinite. Think about that. From the faint hiss of the CMB, we have learned not only about our beginning, but about the possibility that space stretches endlessly, forever. A baby picture of the cosmos turned into a revelation about infinity. And yet, within that infinity, we are finite. The CMB is a reminder of both. It shows us the boundlessness of space, but also the fragility of our moment. The photons have traveled 13.8 billion years to reach us, but their meaning depends on whether we pay attention. And here is where the mirror returns to us. The CMB is not mystical. It is physics measured and mapped with exquisite care. But its lesson reaches beyond physics. It tells us that signals can be faint but real, that meaning can hide in noise, that the universe itself carries memory not as myth, but as light. And so the question comes back to us. What signals are we ignoring in our own time? The warnings of climate science, the alarms of inequality, the lessons of history. The universe whispers through photons across billions of years, and we strain to hear it. But when signals come from our own planet, from our own scientists, from our own neighbors, do we listen with the same patience, or do we dismiss it as noise? The CMB humbles us with its scale, but it also instructs us. The universe keeps records. Light remembers, and so will history. The cosmic microwave background is not just a picture of the past. It is a probe into the very birth of possibility. When we measure its ripples, we are not only looking backward 8 billion years, we are also looking inward into the laws of physics themselves, testing whether our theories of the earliest universe hold true. One of those theories is cosmic inflation. The idea is as audacious as it is elegant, that in the first trillionth of a trillionth of a trillionth of a second, the universe expanded faster than the speed of light, ballooning from subatomic size to something astronomically vast. Inflation stretched quantum fluctuations, tiny jitters in the vacuum, into the seeds of cosmic structure. Those seeds are exactly what COBE, WMAP, and Planck detected in the CMB. This is a staggering thought. Every galaxy, every star, every planet, every moment of beauty or tragedy in human history traces back to microscopic jitters in the quantum foam, amplified by inflation. The randomness of quantum physics became the architecture of reality. Out of uncertainty came structure. Out of fluctuation came us. And doesn't that sound eerily familiar to the human condition? Out of chaos comes meaning. Out of chance encounters come love stories. Out of turbulent history come civilizations. The lesson of inflation is not just about the cosmos, it is about us. That imperfection is not only survivable, it is the soil from which everything grows. But inflation also hints at something more radical, that our universe may not be the only one. If inflation happened once, it might happen repeatedly, endlessly, budding off new universes like bubbles in a cosmic sea. The multiverse, once the realm of philosophy and science fiction, is now a serious possibility. If true, it means that our cosmos is not the cosmos merely one chapter in an infinite library of creation. And yet, within this multiverse, if it exists, our universe still matters. This Earth still matters. This moment still matters. Infinity does not erase responsibility, it sharpens it. For in an infinite sea of possibilities, this reality is the only one we inhabit. And what we do with it is still the measure of our consciousness. Now let us return to what WMAP and Planck also taught us, that most of the universe is invisible. Ordinary matter, the atoms in stars and people, accounts for less than 5% of the cosmos. The rest is a strange shadowland of dark matter and dark energy. Dark matter reveals itself through gravity. Galaxies spin too fast to be held together by visible stars alone. Clusters of galaxies bend light more than ordinary matter can explain. Something unseen, something massive, is shaping the cosmos. That something dark matter outweighs visible matter 5 to 1. Dark energy is stranger still. In the late 1990 seconds, astronomers discovered that the expansion of the universe is not slowing down as expected, but speeding up. Galaxies are racing away faster and faster, as though space itself were pushing them apart. This mysterious push, invisible, pervasive, relentless, is what we call dark energy. It makes up nearly 70% of the cosmos. Think about that. The vast majority of reality is unknown. We live in a universe where the dominant ingredients are invisible, where the deepest truths are hidden in plain sight. And yet, from the tiny sliver we do know, we have built telescopes, medicines, cities, civilizations. We have carved meaning from ignorance. This is both humbling and empowering. Humbling because it reminds us how little we know. Empowering because it shows us how much we can do with what little we have. Consciousness thrives in mystery. Awareness grows not in certainty, but in the willingness to confront the unknown. But here is the paradox. In science, we honor the unknown as an invitation. In society, too often, we fear it as a threat. The cosmos whispers, "You know only 5% of me." And scientists respond, "Wonderful, let's explore." But when life whispers, "You don't understand everything," too often we respond with denial, defensiveness, even violence. What if we lived as though mystery were not danger, but invitation? What if we treated the unknown in human affairs the way science treats the unknown in the cosmos as something to explore, to learn from, to embrace with humility? The CMB teaches us that faint signals, patiently decoded, reveal the deepest truths. But in our own lives, in our own civilization, we often drown faint signals in noise. The warnings of climate science are faint compared to the roar of industry. The lessons of history are faint compared to the clamor of politics. The quiet signals of conscience are faint compared to the temptations of distraction. And yet, just like the photons of the CMB, those faint signals carry everything. The future depends on whether we will listen. The universe has already shown us the pattern. Imperfection seeds creation. Mystery drives discovery. Awareness demands responsibility. The question is not whether the signals are there. The question is whether we will tune our instruments and our minds to hear them. Dark matter and dark energy are not just scientific curiosities. They are reminders that the universe is stranger than our instincts allow. They are the hidden scaffolding of reality, the silent partners in cosmic evolution. Consider dark matter. Though invisible, it holds galaxies together. Without it, the Milky Way would fly apart like sparks from a firework. Without it, there would be no galaxies, no stars, no planets, no us. Dark matter does not shine, yet it enables the shining of everything. And isn't that a lesson for humanity? That what matters most is not always visible. Trust, kindness, cooperation, shared values, none of these can be weighed on a scale, but without them, civilizations collapse. Just as galaxies need dark matter, societies need invisible bonds. Tear them away, and everything flies apart. Then comes dark energy, even more mysterious. If dark matter pulls, dark energy pushes. It is the great accelerant of the cosmos, driving galaxies farther and farther apart. The more space expands, the more dark energy fills it, a feedback loop without end. If this continues, the universe faces a lonely future. Stars will burn out, galaxies will drift beyond sight. Eventually, only silence will remain a heat death, where entropy rules, where nothing new can emerge. Other fates are possible. Perhaps dark energy will grow so strong it rips galaxies, stars, even atoms apart the Big Rip. Or perhaps gravity will one day overwhelm expansion, pulling the cosmos back into a fiery collapse, the Big Crunch. Or perhaps, most astonishingly, the universe is cyclical. expansion, collapse, rebirth, an endless heartbeat of creation. We don't know. The signals are faint, the future uncertain, but whichever fate awaits, one truth is clear. Nothing lasts forever. Not stars, not galaxies, not even universes. And here is the mirror again. Civilizations too face choices of fate. Some burn bright, then collapse. Others fade slowly, hollowed out by neglect. A few transform, finding renewal through reinvention. The universe does not grant permanence, it grants possibility. And possibility requires responsibility. The CMB is proof that memory is woven into the cosmos. Light remembers, space records. The signals are faint, but they are there. And so too with human history. Warnings are written long before collapses come. Rome did not fall overnight. The signals were visible for centuries. The Mayans did not vanish without trace. Deforestation, drought, and division all left their signatures. Civilizations do not collapse because they lack warnings. They collapse because they ignore them. We are surrounded by faint signals now. Rising carbon dioxide, melting ice, record heat, species disappearing, nuclear arsenals still on hair trigger alert, inequality hollowing trust. These are not mysteries, they are signals. The question is not whether they exist, but whether we are willing to listen and act. The cosmos teaches us patience. Photons from the CMB traveled billions of years to reach us. Scientists spent decades building instruments to catch them, and when they listened, they heard the story of everything. What if we approach the signals of our own age with the same patience, the same humility, the same determination to distinguish faint truths from overwhelming noise? The CMB whispers. The universe remembers. The challenge before us is whether we will remember too. If the cosmic microwave background is the baby picture of the universe, then inflation is the midwife that delivered it. This extraordinary idea proposes that in the universe's first heartbeat of existence, space itself expanded faster than light, not carrying objects through space faster than light, but stretching space itself at a speed our minds can barely fathom. Why does this matter? Because inflation explains three puzzles that haunted cosmologists for decades. First, the horizon problem. The CMB is astonishingly uniform, the same temperature everywhere. But regions of the universe, now separated by billions of light years, were never in contact. How then could they have agreed on a common temperature? Inflation solves this. Before the rapid expansion, those regions were in contact, equilibrated, then were stretched apart beyond sight. Second, the flatness problem. Measurements show the universe is geometrically flat. Not curved like a sphere, not saddle-shaped, but flat within a fraction of a percent. Without inflation, achieving this balance would be like balancing a pencil on its tip for billions of years. Inflation stretches any curvature flat, like inflating a balloon until its surface appears flat to an ant walking across it. Third, the structure problem. Where did galaxies come from? Inflation stretches quantum fluctuations, the tiniest possible jitters, into macroscopic ripples, seeding the clumps of matter that grew into stars and galaxies. In one stroke, inflation ties together uniformity, flatness, and structure. It is as if the cosmos whispered three riddles, and inflation offered one answer. But inflation carries a startling implication. If space can inflate once, why not again? Why not endlessly? In this picture, our universe is but one bubble in a frothing sea of universes. Some bubbles expand and cool. Some collapse. Some may have different laws of physics entirely. This is the multiverse hypothesis, radical, speculative, yet mathematically plausible. If true, it means our universe is not unique. It is one chapter in an infinite library. But far from diminishing us, this idea deepens our significance. For in an endless multiverse, meaning still arises locally, we are the only conscious witnesses of this universe, this earth, this history. Infinity does not erase importance, it sharpens it. Because in all the possible worlds, this is the one we inhabit. And how we live within it is the measure of our responsibility. The multiverse also raises humbling questions about knowledge. If other universes exist, cut off from us forever, can we ever know them? Are there truths forever beyond our reach? And if so, does that diminish science? No, for science has never promised omniscience. Science promises humility. It is the practice of drawing meaning from the signals we can detect while acknowledging the vastness of what we cannot. The CMB is a perfect example. It is a signal within reach, faint but real. We did not throw up our hands and say, too faint, too noisy, too difficult. We built better instruments, sharpened our patience, and listened. That is the model for how to face every mystery, cosmic or human. And here is where the cosmic mirrors the human yet again. We do not know everything about the universe, but neither do we know everything about ourselves. The human mind, too, has its horizon problems, its hidden matter, its accelerating forces. Consciousness itself is our greatest dark energy, invisible, intangible, yet shaping everything. And just as we map the CMB to glimpse the universe's infancy, perhaps one day we will map the neural background of thought, uncovering the faint signals that make us who we are, but the lesson remains the same. Faint signals carry deep truths. The question is whether we will listen. The universe, in a sense, has already shown us the blueprint. Photons carry memory across billions of years. Ripples seed galaxies. Inflation stretches tiny fluctuations into vast structure. If the cosmos can amplify the smallest jitters into galaxies, then surely we can amplify the smallest acts of kindness, of wisdom, of responsibility into civilizations worth remembering. And so the stage is set. We have decoded the secret signals of the CMB. We have glimpsed inflation, dark matter, dark energy, even the possibility of the multiverse. But now the mirror turns fully back to us, because the question is no longer, what does the universe remember? The question is, what will humanity choose to remember and to scatter forward? When we gaze into the CMB, we are looking at the beginning. But science, restless as ever, asks not only where we came from, but where we are going. The fate of the universe depends on a balance of forces: gravity, dark matter, dark energy. And from this balance emerge several possibilities, each with its own poetry of ending. The first is the big freeze, sometimes called the heat death. In this vision, dark energy continues its quiet work, accelerating the expansion forever. Galaxies drift farther apart. Stars burn through their fuel, leaving behind white dwarfs, neutron stars, black holes. Even black holes, over unimaginable timescales, evaporate through Hawking radiation. What remains is a thin, cold mist of particles too diffuse to form anything new. A universe of silence, stretched thin until novelty ceases. Infinity drained into emptiness. The second is more violent. The Big Rip. If dark energy grows stronger with time, it could overcome every force first tearing galaxies apart, then solar systems, then planets, then even atoms themselves. Space itself would unravel. The universe would not fade into silence, but shatter into nothingness. A cosmic crescendo ending in rupture. The third is the Big Crunch. Perhaps gravity, hidden in dark matter, will one day overwhelm expansion. Galaxies would slow, then reverse, collapsing inward. The universe would grow hotter, denser, until it folds back into a singularity. An ending that echoes the beginning. And some suggest this might not be final, that a crunch could trigger a new bang, a rebirth. In that case, the universe is not infinite, but cyclical. Creation, collapse, renewal, a heartbeat, writ across eternity. And then there are hybrid visions, bounces and branchings. Perhaps every collapse triggers new universes. Perhaps black holes seed daughter universes on the other side of their event horizons. Perhaps inflation is eternal, bubbling off new realities endlessly. If so, our universe is a single verse in an infinite cosmic song. Each scénario settles. Each denies us the permanence we crave. We like to imagine the cosmos as eternal, stable, everlasting. But the signals of physics whisper otherwise. Stars die. Galaxies drift. Even universes may end. And yet, hidden in these endings is a deeper lesson, meaning does not require eternity. In fact, it flourishes because of impermanence. Stars shine because they burn out. Galaxies form because ripples broke uniformity. Civilizations matter because they rise and fall. Lives are precious because they end. If the universe were eternal, unchanging, infinite in every direction, then nothing would matter. In an endless static infinity, novelty is impossible, urgency irrelevant, meaning dissolved. It is finitude that sharpens significance. The CMB itself is proof. If the universe were truly infinite in the past, with no beginning, there would be no CMB, no record, no memory. It is precisely because the universe had a birth, a moment of emergence, that signals exist at all. The faint hiss Penzias and Wilson heard was only possible because the universe is finite in age. Memory requires beginnings. Meaning requires endings. And here at last, the cosmic mirror turns fully toward us. Because if even universes can end, what does that say about civilizations, about cultures, about lives? If infinity is not guaranteed, then responsibility cannot be deferred. We must act within limits. We must live within finitude. The cosmos is not eternal comfort. It is a challenge. It asks us, given that time is finite, what will you do with yours? Given that resources are finite, how will you use them? Given that consciousness is fragile, how will you scatter it forward? The signals are there, in photons stretched across billions of years, in ice cores drilled from Earth's poles, in the lessons of history etched into ruins and records. The signals whisper the same truth. Nothing lasts forever. And in that truth lies the reason to care, to act, to build, to scatter meaning. At the heart of every cosmic fate lies one quiet, relentless principle: entropy. Entropy is often misunderstood as disorder, but in physics, it is subtler and more profound. Entropy measures the number of possible arrangements of a system, the spread of energy, the dispersal of possibility. A deck of cards neatly ordered from ace to king has low entropy. Shuffle it and entropy rises. Energy spreads. Order gives way to probability. The second law of thermodynamics tells us that entropy always increases in closed systems. Heat flows from hot to cold. Stars burn fuel, never the reverse. Glass shatters, never reassembles. Time, in fact, is nothing more than the direction in which entropy increases. The arrow of time is written in the language of entropy. And so when we speak of the universe's fate, we are really speaking of entropy's story. The CMB itself is a record of entropy rising. In the first moments, energy was compressed into dazzling uniformity, but uniformity is unstable. Tiny fluctuations grew, clumped, collapsed, ignited stars, sculpted galaxies. Complexity emerged, temporarily defying the drift toward equilibrium. But the second law cannot be cheated forever. Stars exhaust themselves. Galaxies thin out. Entropy rises. The universe moves inevitably toward equilibrium, the heat death, where energy is spread so evenly that nothing more can happen. This raises a haunting question. If entropy always increases, how did the universe begin in such a low entropy state? Why was the opening act of reality so improbably ordered, like a cosmic deck stacked perfectly in sequence? The CMB is the smoking gun of this mystery. It shows us the young universe was astonishingly smooth, almost featureless low entropy with only faint ripples to break the perfection. Those ripples became everything. In a sense, the story of the cosmos is the story of entropy turning simplicity into complexity, smoothness into structure, perfection into imperfection, and finding beauty there. The galaxies, the stars, the planets, even the emergence of life itself, all are temporary islands of order carved from entropy's tide. And here is the reflection. Our lives, too, are temporary islands of order. Our bodies resist entropy for decades, but not forever. Our civilizations resist collapse for centuries, but not eternally. Entropy comes for all, but within the temporary defiance of entropy, meaning flourishes. Think of it this way. If entropy guarantees that everything scatters, then our role is to decide what we scatter. Stars scatter elements, supernovae scatter enrichment. Civilizations scatter ideas, art, knowledge. Individuals scatter love, memory, responsibility. Entropy is inevitable, but what we scatter is not. Even time itself is tied to this law. The past is fixed because entropy has increased. The future is open because entropy has not yet unfolded. Time is not simply a river carrying us forward. It is the blossoming of possibility from the unlikely smoothness of the beginning. The CMB is the echo of that improbability. And so when we look at the faint microwave glow across the sky, we are not just seeing ancient light. We are seeing the arrow of time itself. We are seeing the proof that our universe began in improbable order, and that everything we value, life, love, thought, art, is a fleeting but magnificent pause in entropy's climb. This is why the CMB is more than science. It is philosophy. It tells us that nothing lasts forever, and that this is not despair, it is meaning. It is responsibility. Because the question is not whether entropy wins. It always does. The question is, what will we scatter before it does? Time is the most intimate dimension of our lives, yet also the most mysterious. We move through it effortlessly, as though it were a river flowing from past to future. But what is time really? The cosmic microwave background offers clues, because it is not just light, it is time made visible. The photons of the CMB began their journey 8 billion years ago, when the universe first became transparent. To us, they are a message from the past. But to those photons, no time has passed at all. Traveling at the speed of light, they have experienced the universe as one unbroken instant. From their perspective, the journey from the dawn of creation to the detector in a modern telescope was instantaneous. This is relativity's first great lesson. Time is not absolute. It bends, stretches, dilates. A clock on a spaceship traveling near light speed ticks slower than a clock on Earth. A clock near a black hole runs slower than one far away. Time is woven with space into a fabric space-time, and that fabric can warp, but relativity goes further. It tells us that past, present, and future are not as distinct as we feel them to be. To us, the present feels real, the past is gone, the future not yet here. But in space-time, all events simply are like points on a map. The CMB is one such point, frozen forever. So are your childhood, your tomorrow, and the final fate of the cosmos. Time may not be a flowing river, but a landscape, and our consciousness is the traveler moving through it. If that is true, then meaning is not erased by impermanence, it is secured by existence. Every laugh you have ever laughed, every act of kindness you have ever offered, every choice you have ever made, they remain etched into space-time, like signals in the cosmic background of your life. You cannot erase them. You can only add to them. The CMB is the universe's memory. Our actions are our own. Just as photons carry the imprint of density fluctuations across billions of years, so do our choices carry imprints forward into the lives of others, into the legacy of civilization, into the history that will be remembered long after we are gone. And here lies the paradox. Time is both finite and infinite. Finite for us, infinite for the universe. Finite in the span of a life, infinite in the persistence of memory. The real question then is not how much time we have, but what we do within it. The cosmos has already given us its gift. Improbability, order, the chance to exist in a fleeting moment of clarity before entropy dissolves it all back into uniformity. The photons of the CMB remind us, even beginnings fade. The arrow of time does not pause. But while it lasts, we have the extraordinary privilege of choice. We cannot stop entropy, but we can decide what to scatter into it. Wisdom or folly, compassion or cruelty, meaning or silence. The CMB is not only a scientific signal, it is a cosmic mirror. It asks us, given that even universes end, what will you do with your moment in time? Civilizations, like universes, carry within them the seeds of their own fates. They too are governed by laws as unyielding as physics, even if the equations are written in human behavior rather than in stars. Every great civilization has believed itself permanent. The Egyptians built pyramids as monuments to eternity. The Romans called their capital Roma Aeterna, the eternal city. The dynasties of China invoked the mandate of heaven as though it could never expire. The Mayans built calendars stretching farther than any one generation could grasp. And yet, each of these civilizations faced entropy, not in the physics of heat, but in the slow erosion of trust, balance, and responsibility. Collapse, like entropy, is not a single moment. It is the accumulation of ignored signals. Crops fail, forests thin, inequality widens, trust erodes, armies stretch too far, leaders mistake short-term power for long-term stability. From the outside, everything still looks strong, just as a star still shines, even as its core runs out of fuel. But inside, the countdown begins. Rome did not fall in a day. The Mayans did not vanish in an instant. Warnings were written into their own background radiation, subtle signals visible to those willing to measure them. But the signals were ignored. And here we are in our own century, surrounded by signals. The planet warms, the seas rise, species vanish. Nuclear weapons linger in silos, enough to erase humanity many times over. Inequality deepens, trust fractures, misinformation spreads faster than truth. These are not mysteries, they are measurements. They are as real as the ripples in the CMB. The question is not whether the signals exist. The question is whether we are willing to listen. The paradox of our time is stark. We have instruments that can detect the faintest whisper of photons from the edge of the observable universe, but we often fail to hear the clear warnings from our own Earth. We have mapped the beginning of time, but we are deaf to the signals of our present. The CMB teaches us patience. It teaches us humility. It teaches us that meaning hides in faint signals, not in noise. What if we approached our civilization's alarms with the same care? What if we treated the melting of ice sheets with the same seriousness we give to fluctuations in the cosmic background? What if we tuned our moral instruments as finely as we tune our radio telescopes? Because here is the truth. The universe does not care whether humanity survives. Stars will continue to burn. Galaxies will continue to spin. Entropy will continue to rise. The cosmos is indifferent, but we are not. We care. We are the ones for whom survival has meaning. And that is what makes our role unique. We are the only known species in the universe that can detect the signals of its own fragility and act on them. Stars cannot choose whether to collapse, but we can. Civilizations cannot avoid entropy forever. But we can decide how to scatter what remains. The CMB is the record of the universe's beginning. What record will we leave? Will future beings, if they exist, look back at our century and see a species that ignored its own signals, scattering only ashes? Or will they see a species that listened, that acted, that scattered enrichment into the future? This is our cosmic test, not whether we can build telescopes to study the past, but whether we can build wisdom to shape the future. Not whether we can decode faint photons, but whether we can decode the faint signals of conscience, responsibility, and foresight. Because the universe has already whispered its truth. Nothing lasts forever. Not stars, not galaxies, not civilizations. The question is not whether we will endure forever. It is whether we will scatter meaning while we last. The 20th century was humanity's first rehearsal for cosmic adulthood. For the first time in history, we built machines capable not only of crossing oceans or continents, but of leaving Earth altogether. Rockets rose from deserts and swamps. Astronauts strapped themselves into fragile capsules, and humanity took its first steps into the void. On the surface, it was rivalry, the Cold War, superpowers locked in a dangerous competition. The United States and the Soviet Union built rockets not out of shared curiosity, but out of fear. Yet history has a way of twisting motives into outcomes far greater than intended. Out of rivalry came revelation, out of fear came perspective, out of competition came cooperation. When Yuri Gagarin became the first human in space in 1961, he looked down and saw Earth whole, without borders, without divisions, fragile against the blackness. When Apollo 8 circled the moon in 1968, astronauts captured the now famous photograph of Earthrise, a blue and white marble rising above the barren lunar horizon. And when Apollo 17's crew looked back in 1972, they gave us the blue marble image, the entire Earth, luminous, finite, breathtaking. These images were more than photographs. They were mirrors. They showed us that we are one species on one planet suspended in vast darkness. They revealed that our divisions are illusions, our conflicts petty, our responsibilities immense. And then, in 1990, Voyager 1, already beyond the planets, turned its camera back toward Earth at Carl Sagan's request. What it captured was humbling. A single pixel, a pale blue dot suspended in a sunbeam. On that dot is every king and peasant, every saint and sinner, every invention, every war, every love, every life. All of human history, compressed into less than a pixel. Sagan reflected, that's home, that's us. The pale blue dot is our version of the cosmic microwave background, a signal not of the universe's birth, but of our fragility, a signal faint but clear. Earth is finite, life is rare, consciousness is fragile. Responsibility is non-negotiable. The space race taught us this paradox, that when we reached outward, what we discovered was inward. We chased the moon and found Earth. We sought infinity and discovered finitude. We dreamed of other worlds and realized the urgency of caring for our own. The CMB whispers the memory of the universe's infancy. The pale blue dot whispers the truth of our fragility. Both are signals. Both are faint. Both demand attention. And so the cosmic mirror becomes clear. The same patience and humility with which we decoded the CMB must be applied to our own world. The same commitment to listening, to separating signal from noise, must guide us now, because the signals of crisis are everywhere. In the atmosphere, in the oceans, in the soil, in the trust between nations and neighbors. The space age gave us the tools to reach other worlds, but it also gave us the perspective to finally see our own. The question is whether we will honor that perspective. Because if the universe keeps records, so does history. If photons remember the birth of galaxies, then surely future generations will remember what we chose to do in our moment. And so just as COBE, WMAP, and Planck mapped the faint ripples that seeded galaxies, we must now map the faint ripples of our own century. The signals are faint, but they are there. The question is not whether they exist. The question is whether we will listen and act. So the universe has already spoken to us. In faint whispers across billions of years, in photons stretched thin by time, it has given us the cosmic microwave background, a baby picture of everything. Proof that imperfection seeds creation, that memory is woven into light itself. And in a single fragile pixel, a pale blue dot suspended in a sunbeam, it has reminded us that fragility is truth, and responsibility cannot be postponed. Both signals, the ancient and the modern, the cosmic and the human, are easy to ignore. The CMB was once dismissed as noise on a radio antenna. The pale blue dot could be mistaken for dust on a photograph, but to listen, to look closer, is to find meaning. That is the lesson. The question now is whether we will treat the signals of our own age with the same reverence. The rising carbon in the air, the thinning of forests, the warming of seas, the divisions among nations, these too are signals. Faint perhaps against the noise of politics and distraction, but no less real. The CMB taught us patience. The pale blue dot taught us humility. Our century demands we learn responsibility. We are the only known species in the universe that can detect the signals of its own fragility and choose to act. Stars cannot choose to resist entropy. Galaxies cannot choose to resist drift. That is our gift and our burden. And so the real question is not whether the universe is sending us signals. It always has. The real question is whether we will listen and scatter, meaning instead of silence. If the cosmos remembers its infancy in photons, let us ensure it remembers our civilization in wisdom. If stars scatter elements into galaxies, let us scatter knowledge, compassion, and responsibility into the future. If the universe has granted us awareness, let us prove worthy of being its consciousness. Because one day, if another intelligence here or elsewhere looks back at us, may they see not only that we existed, but that we listened, that we cared, that in our finite time, on our fragile world, we lived as though consciousness mattered. The cosmic microwave background tells us where we began. The pale blue dot tells us how fragile we are. The rest of the story is up to us. May we choose to hear the signals. May we choose to act. May we choose to scatter meaning before the universe goes silent.